Okay, so continuing on in example 3, part B, we have to show that the two triangles are similar and write a similarity statement. Okay, so we finished part A. And over here, this is another classic example that you will see in geometry textbooks. Basically, you have a triangle within this big triangle right here. Okay, so hopefully everyone can see that there's a small triangle here and then there's a big triangle here, right? And somehow I have to show that this is similar to this. So again, the parallel lines right here will pretty much give away on showing how to prove that they're similar. And again, whenever you have parallel lines, just like the previous problem, right, you wanted to use alternate interior angles or any of your parallel line theorems that apply. And actually, in this previous example, I was going to say that you can also show that these two angles are congruent by vertical angles. Okay, so if somehow you use vertical angle theorem, that would have been okay as well. And likewise, there's multiple ways to prove that this small triangle is similar to the big triangle. So I have parallel lines over here. The first thing I could say is that, hey, angle CBD is congruent to angle CAE. Angle CBD is congruent to angle CAE. Now, again, the Y is important, right? It's not because I just think they look similar or they look congruent. It's because your parallel lines theorem that states if you have two parallel lines and you have a transversal, the corresponding angles are congruent. So I'm going to say they're congruent by, I'm going to abbreviate corresponding angles. Okay. In the future, you could just say CAT. Okay. Corresponding angle theorem. That if you write that in your notes or homework, I'll know what you mean by that. Okay. All right. Well, these two angles are congruent, right? I only need one more set. You could say angle C is congruent to itself, right? The small triangle has angle C. The big triangle also has angle C. And you could say bireflexive. Okay, now that we established that two angles are congruent, this angle is congruent to this, angle C is congruent to itself, you could say, again, when you say the similarity statement or when you write it down, make sure everything lines up. Okay, so I'm going to say triangle CBD, the small triangle, is similar to triangle CAE, the big triangle. Okay, so notice I went based on my arc mark, double arc mark, single, none, double arc mark, single arc mark, no arc mark. Okay, so you have to be consistent. You can't just randomly state the letters in any particular order. Okay, it has to, similarity statements, the position or the ordering of the letters matter. Okay, now some of you might be thinking, well, there's another way I can prove that they're similar, and you're right. I mean, if you stated that, hey, angle CDB is congruent to angle CEA, also by corresponding angles, you could have done it that way as well instead of using the reflexive property for angle C. Okay, so that will conclude example 3. And we're going to move on to the very last example, which is a pretty short and sweet example of finding x. Again, when you see a problem like this, which you will probably see on an SAT or ACT, they love asking these standardized test type questions of similar triangles. Again, when you have a small right triangle and you have a big right triangle, just realize that the big triangle right here is similar to the small triangle right here. And why is that? It's because we learned our angle theorem, right? So if the big triangle right here has a right angle, the small triangle right here also has a right angle, right? If this is 90, of course, this is also going to be 90. So they both have that 90-degree angles, right? And, you know, the right angle theorem, which I have written right here. Okay, I'm kind of looking at my notes. All right angles are congruent. So 90 is congruent to 90. And then both the big triangle and the small triangle share this angle right here, right? The big triangle has this tiny angle. The small triangle has this tiny angle. So you know that this big right triangle is similar to the small right triangle. Okay, so that was a little bit of a lengthy explanation on explaining why they're similar, but I mean, that was kind of the point of today's lesson. Okay, now that you know that the small triangle is similar to the big right triangle, you can solve this no problem. Okay, so again, the proportion, the order of the letters or your variables and numbers matter. So I'm going to go from smaller leg to longer leg on the small triangle, small to long, x is the 6, as smaller leg to longer leg on the big triangle, 2 is the 24. Okay, so you could have gone 6 is the x, is 24 is the 2, it doesn't really matter. And then, of course, you can cross multiply and solve. Okay, so 24x is equal to 12, x is equal to 12 over 24. Make sure you write down units. The 1/2 is 1/2 feet. Okay, so 0.5 feet will be my final answer.